you do that, you need to really shake it off, let it go. You know, Mr. Bean's gonna bean. Oh, I can't believe I said that. Math teacher gonna teach. All right, moving on. Let's get into this section. This is going to be a great chapter. Let's start it off here. So we're going to take functions and transform them. So luckily, we've done a lot of this in our algebra review skills. So I'm going to move quickly in the beginning because hopefully you've been practicing along the way. Just want to make sure we get a couple ideas here. We're going to take any kind of function in the world out there. So we have our ones that we like to look at. Parent function, maybe it's a parabola, y equals x squared. The parent function is the most basic thing possible, the simplest form possible, the f of x. What am I going to do with the f of x? So I can say y equals, or maybe I'll say the f of x. Maybe I'm talking about absolute values, but I'm not doing anything. That's the parent function, that's the original. So down here, I'm going to use this little function, and hopefully you can see it here. This is like kind of like a half a circle here. Woo! Something like this. And I'm going to use Desmos here. This is really cool if you want to go to desmos.com to manipulate it. But I'm going to do these different transformations to this is going to the function I'm going to use. This is going to be my f of x right here. And I'm going to call that my parent function that I'm going to do stuff to it. So translations, this is what we really hammered on. Translation means to move left, right, or up and down. Or as Snoop Dogg would say, it's something like this. Now we're talking. So if I want to do a vertical shift, remember you're going to take your function and add 2 to it. So that's going to move it up or down. So this is your up or down portion. And then if you want to do a horizontal shift, this is going to be your left or right. Remember, it's inside of the parentheses, and it's kind of always opposite. This would actually move it right too. So it's kind of opposite in here. When it's outside the parentheses, this would be an up to, no worries. So check out my little Desmos app of this thing being translated all around. Cool. It almost kind of looked like a Windows screensaver there for a second. All right. Let's move on and do some problems. So if I give you the parent function of this, I'm going to give you a parabola or quadratic function right here. Describes the translation. So I like to start out here. I know that's going to be what? Down. So we're going to call that a vertical shift down, and I know a lot of people are going to like writing this out every time. Vertical shift down 5, but it is a shift down 5, so make sure we write that all out. And then what is this? This is going to be a horizontal shift. I mean, I know you could abbreviate to vert shift or hor shift, but that doesn't sound so. It's going to be a horizontal shift. And remember, it's opposite what you would think. A negative would be left, but it's opposite of what you would think. This is going to be right 3. So that is going to be right 3. Excellent. Moving on. What if I go ahead and give you another parent function, square root function, and I want you to write the equation of all this stuff. So I'm going to do a vertical shift of up 5, horizontal shift of left. So not a problem here. My function will be what? If I want to do horizontal, it's going to be inside the grouping symbol. So in this case, it's square root. And inside of here, I'm going to say, yeah, I'm going to move it left. So that would be plus 17. Then outside the grouping symbol, I'm going to go up 5. So again, opposite of what you would think, to go left would be plus. Fantastic. Awesome. That's translations in a nutshell. Moving on. Now this is going to be new for us. Now we're going to kind of do like scalar multiplication. We're going to make everything bigger or smaller. Or as I like to think of this, I like to think of my favorite artist, Biggie Smalls. Biggie Smalls. So we're going to make it bigger or smaller. So what I'm going to do is I'm going to take a vertical stretch instead of like our shift. This is going to be, we're going to stretch it out bigger or shrink it smaller. So when I put the number in front of my function, this is going to be a stretch. This is a vertical stretch of 2. If I put a shrink out of here, if it's less than 1, it's going to be a vertical shrink of 1/2. So how about this for horizontal? Remember, it goes in your grouping symbol, and it's opposite of what you would think. You would think, why isn't that shrinking it? It's not. It's opposite. That stretches it 2. What does this do then? You're right. That shrinks it 1/2. So it's kind of opposite of what you would think. Check out, listen to some Biggie Smalls and check out this Desmos of my function being stretched and shrunk. All right, now let's apply it to some problems here. So if I give you, I like to start with something that you can realize is this this actual quadratic here. So describe the scale in this. So I know there's a translation. I know this goes right 3 down 5, but I'm most concerned about this. What does this do? This is a, whoa, my handwriting's really bad, vertical Is it stretching it out or shrinking it? Sometimes this is called stretch or compress. You can see some different terms for this, but this is going to be a vertical. We're going to go with stretch. A vertical stretch of what? That's our factor 4. We made everything 4 times bigger, so that parabola would be 4 times stretched in the vertical direction. Awesome. How about this one? Oh, we're getting tricky already. Let's bring it. Let's do it. If I was looking at this, this is weird. It's a little bit different. We actually have to rewrite these. So I'm actually looking for the number in front of x. Well, I can see it's 2. A safe practice to get into is to go ahead and factor that 2 out. I'm going to factor that 2 out. And what happens if I pull the 2 out, if I undistribute the 2, what's left? Well, yeah, that's going to be minus 4. So this is really the nicer way to write it. Yeah, that's fine. That works. It's great. But now I have a much better scene. I'm in the grouping symbol. The number in front of x was 2. So what does that mean? If it's in the grouping symbol, it's a horizontal. And what is that? Remember, it's opposite of what you would think. It's a shrink. That rhymed. So that's going to be of 1/2. So really, that's what's happening. The reason I like it factored is because now could you tell me the translation? Sure, this actually went right 4, down 5. Up here, it's kind of hard to see that. So get in the habit, if there's a number in front of the x, we're going to go ahead and factor that out of there. Ooh, I love it. Love it. All right, moving on over here. Write the equation. So I've got a cubic function. I want you to do all of this to it. So I'm looking at this. To me, is I've got this shrink factor going on. I've got a vertical shift down. Is that it? I think that's it. So I'm going to go ahead and you can say y equals f of x. It's the same difference here. I'm going to go y equals, and let's take care of that shrink. So it's got to be in the grouping symbol, and it's a factor of 3. So remember. Oh, Michael, I almost messed up there. Let's change that. I'm going to say what? It's a shrink of 3. I can write it straight up. It's opposite of what you would think. So it's 3x cubed. That will give you a shrink factor of 1/3. And then I want to move it down. I'm just going to go minus 5 over here. Awesome. How about this one? Write a function with a horizontal shift right, vertical shift up 3, and a vertical stretch. Oh my goodness, this has got everything. So let's take my function. I know the parent function is a cubic, and I like to start in my parentheses. Is there anything horizontal? There's a horizontal shift going on right 2, so I'm going to start with that. So I'm going to say, hey, horizontal shift right 2, opposite of what you would think. Then I'm going to do the vertical shift up 3. Boom. Now can I add a vertical stretch by 4? Sure, and this is the one that is what you would think it would be. So there it is right there. Boom. Got it. Love it. That is scaling it. So you're making these things more stretched. Is that a word? Stretchier? More stretched? All right, so reflection. Let's take a look at this. What we're going to do is we're going to do vertical reflections and horizontal reflections. But as long as we do them first, we can go ahead and say that we're reflecting about the x-axis. So when you see this negative in front, it means you're going to reflect it about the x-axis. If you see it in the parentheses, it's a horizontal reflection. Everything in here is horizontal. It's going to reflect it about the y-axis if you do it first. So we're going to always assume that we do it first. So for example, all right, so let's have a function over here, and maybe it's some kind of square root function like this. So maybe it does this, and we've got ourselves a nice square root function here. So let's say we have this function, and I want to do these different things. I want to do a vertical reflection, or in this case, it's about the x-axis. So here's the x-axis. I like to draw this to let me know that that's what I'm spinning around. And when I reflect it, when the negative's in front, I'm just going to flip it over this. So I'm going to flip it over. That dot comes down here. That dot comes down here, that dot comes down here, and then your square root's been reflected about the x-axis. Awesome. And how about a horizontal reflection or about the y-axis? Boom, I'm going to reflect around this. So again, this is like my axis of symmetry, or I'm going to fold the paper there. Boom, this point flips over here. So we're just taking the points, flipping them to the other side. Again, this is something we're going to assume we always do first. So that we can use this reflect about the x and y axis. Awesome. All right, let's take a look at what it looks like with an equation here. So let's describe the reflection given this function right here. So when I'm talking reflections, I see this negative out here. This is going to be where our vertical stuff happens outside of parentheses. So this would be a vertical reflection right here. Awesome. So the negative is on the outside. That's going to rotate it around the x-axis, but we're going to call that a vertical reflection. Fantastic. What about down here when the negative's on the inside? So that's weird to look at it like this. So I'm going to rewrite it real quick, and basically that says negative x plus 4. So I like that x first,
And what else do I have to do? I can't have this negative x here. I mean, you can, but it's hard to see what's really going on. So what I'm going to do is I'm going to leave everything the same here, and I'm going to distribute out a negative. I'm actually going to factor out a negative. So factor out that negative. So if I take a negative out of the x, it becomes positive, but I take the negative out of the 4. Boom. So it was positive. So really what I did is I undistributed a negative right there. So if I put, negative times x would be negative x, negative times a negative 4 would be plus 4. It's the same thing, but what's nice about this is now I can see everything I need to see. This moves it right forward now, where before it was harder for me to see that. So it moves it right forward. Got that vertical stretch. I'm shifting it down 5. Aha, what does this negative do? This is going to give me the horizontal reflection. So when it's in the parentheses, horizontal reflection, let me spell that bad boy out. When it's in the parentheses, it's going to be your horizontal. When it's outside, it's going to be your vertical. Fantastic. So what happens if I come over here and say, okay, parent function is absolute value. Write the function that has all of this fun stuff. So you can pause it and try it if you like, or you can come along with me here. So when I'm talking vertical shift up 1, I know I'm going to do what? I'm going to add 1 to the end and a vertical reflection. Oh, this is nice. So I just take the parent function, put that bad boy on the outside as my vertical reflection. That's going to flip it upside down, and I'm going to shift it up 1. Fantastic. So not a ton going on there. I like that one. All right, let's take a look at the last one here. I've got a lot going on. We've got this vertical shift that we'll take care of. We've got a vertical shrink. I'm sorry, a horizontal shift, vertical shrink, and a horizontal reflection. So there's a ton of stuff going on. Let's start to build this bad boy right here. This one's tricky. So I'm going to start, we can start inside the absolute value here. So if I start inside the absolute value, I need to take care of this shift left. So I'm going to do something like this. To shift it left 2, I'm going to go plus 2. So there's my shift. I've got this vertical shrink by a factor of 5. Remember, that's kind of weird. This gets confusing. That's like saying it's shrinking by a factor of 5, or it's 1/5 of the original. So the factor is a shrink of factor 5, which is like you're shrinking it 1/5 of its normal size, so that 1/5 is going to go out here. Then I've got a horizontal reflection, so no shift up or down. Horizontal reflection is inside of here. Be careful when you add this bad boy. You can't just put the negative like this. You put the negative in here, but what do you have to do? You have to make sure this is in parentheses. So now I can still see it's shifted left 2. That's going to take care of my horizontal reflection, and that is my 1/5. If you want to, you're more than welcome to distribute it. It's fine either way. I like to see the top one because it's easier for my brain to kind of see what's going on. But if you want to distribute that, you're more than welcome to say either one of these. So that's a big fat or. Either one of those will work. Fantastic. Moving on. All right, so what functions should you know, and what about them should you know? So we're going to go through them all, and to make sure that we can actually draw these, let's fill in the quadratic function. It starts as 0, 0. There was this up 1 over 1 is the most basic, and there's that 1, 3, 5 rule where you go up 1 over 1, then up 1, 2, 3 like this. That's a nice little trick for the basic, but really if you have the vertex and then a point on your side, you're good to go. So that's our most basic quadratic. So here is the function for it down here. So what are the main points here? We've got this h and k and a. Well, this is your h and k. In this case, it's the vertex of the parabola. This is a parabola for the quadratic function. So what are all these pieces? Well, look at a. What is a causing out here? A is causing the vertical scale. So this is going to be the vertical, what? Stretch, shrink, something like that. So that's out front. What does the B cause? Well, I don't even see a B, so let's hold off on that. It's not even there. What does H cause? This is going to be what? A horizontal, right? Shift. I don't know, it's going to go left or right. And then what is this going to cause out here? This is my vertical shift. So up or down. So that's what each piece does. HK B, what is the B? Well, really, this is the generic formula. Like, you'll see this is a vertex form of parabola, but technically there is a B in there. How does that B look? Well, you have to, like, factor it out. This is really will show everything. And what do you think that B does there? Aha. That is going to be your horizontal scale or your stretch. Look at that handwriting. That's so good. I think I put too many C's in there. Let's just make that T bigger. Stretch, shrink. I hope you are listening to the audio on this so you can hear it. That's stretch and shrink. So everything has a B, even the cubic function. Even if they don't write it, we are going to write it in there.
we're going to pull the b out, and it goes right in front of this. So you can use double parentheses if you like. I did double parentheses here. Technically, I think brackets would be nicer because you've got parentheses in a parentheses, so we're going to bracket it up. But we'll know what you're talking about there. Can I draw a cubic? Sure, cubic starts here, and then the next point, it is 1 and 1 here, and it kind of is doing something like this. That is a cubic. It's like a parabola, but the left side went down to negative. So it's like flip that over, boom. You've got that going on. So where's h and k in this one? I'll make sure you know where h and k is. H and k is the origin. This is like a point of inflection. This is just the main point that gets moved around here. So h and k is very important here. Absolute value, the basic absolute value, again, it starts at 0, 0, and it's a nice straight line each direction, up 1 over 1, up 1 over 1. That's the most basic one right there. And again, where's h and k? This is again called the vertex of it. If you wanted to factor out the b in this case, we're going to say b times this right here. Killing it. All right, and then the other one I want you to know is the square root function. So it's here. The first one, square root of 1 is 1. You could probably go out 1, 2, 3, 4, and up 2 is the next one I know the square root of. Square root of 4 is 2. That's a rough square root function. Again, where's h and k in this bad boy? So this is not really the vertex. This is just kind of like its starting point, but that is what actually gets translated around. If you had to find b in this case, what would happen? You'd have to factor it out. You'd have x minus h plus k. So in that grouping symbol, we're adding that b. Woo! Holy cow, I'm talking fast. Pause it, slow me down if you need to. 4 more functions that I want you to know and be able to work with here. Exponential functions. So we're going to just use like base 2. It's going to cross here at 0, 1. It has an asymptote at y equals 0. Boom. This is our exponential function right here. So something along those lines. And again, where's the h and k? It is this point right here is the h and k. So in this most basic parent function, it's the point 0, 1, but that's definitely going to change as you do some different things here. So this is 2 times a times 2. Well, I'm going to rewrite that because that looks really sloppy. It looked like a q. I didn't know what was going on there. Let's try that again. So it's going to be a times 2 to the what? We're going to pull the b out. So it's up here. So it's going to be kind of weird to mess with it up there, but you can. Plus k. Fantastic. Moving on. A log, remember that's the inverse of an exponential function. So in this case, if you don't write it, it's log base 10. I'm not too concerned about what base. You know, we could have made that 3, 4, blah, blah, blah. But I do want you to know this. There is a vertical asymptote here, and it crosses here at 1. It's the same thing, just kind of reflected over. Boom, like this. So that is the log. So it does go on forever and ever. It follows that asymptote. We just flipped that out. Remember, we're switching our x's and y's here. And this becomes what? This is now our h and k of this function. So 1, 0 is actually it. If I wanted to solve for b, it's going to be a log, whatever the base is. And I'm going to say b is in here. And plus k. So the horizontal is inside. Awesome. Here's maybe a new one for you guys. I think Mr. Bean uses an application, the greatest integer function. So this means the greatest, this is like the rounding function, like you're rounding down. It's the greatest integer not greater than function. What in the world does that mean? Well, let's say I have the number, let's say I'm going to fill out a table. If I don't know what I'm doing, I can always fill out a table. And let's say I have the point 4.5. What is the greatest integer not greater than 4.5? Integers means no decimal, like a whole number, positive or negative. So what's the biggest number not bigger than 4.5? It is 4. So I'm going to continue. Anything in this range is going to make 4, isn't it? Until what happens? Until I actually hit 5. What is the biggest integer not greater than 5? Well, the biggest integer not greater than 5 is 5. So what in the world is going to look like? It's going to look something like this. It's going to be open dot, boom. It's like a step function. Jumps up, jumps up, jumps up, there, jump up, jump up, jump around. Oh man, so I'm kind of a little bit off, but those are all open circles on the right side. It means it's not going to be defined there. So let's make sure this worked out. At 4.5, I said the y value is 4. That's the greatest integer not greater than. So go out to 1, 2, 3, 4 and a half. Where does this thing go? 1, 2, 3, 4. There it is. And at 5, it jumps up. So it's a solid dot on the left, open circle on the right. That's when it does its jumping. So sometimes it's called the step function. Boom, it looks like steps. So again, we're going to move this bad boy up, down, left, right, stretch it out. It's going to be a good time. Excellent. If you had to go ahead and put the b in here, remember this greatest integer. It's got 2 lines in there. It's going to be b
x minus h plus b. Oh, I put a b there. That's a k. I hope I fixed that in your notes. If not, fix that. My bad. That should be plus k. Just see if you're with me. Where is that k? I'm glad that was a reminder. Here's the k. It's the origin. That's going to be the point moved around. Holy cow, the finale. So, a lot of these functions we're going to get way more in depth with. And this exponential, Mr. Sullivan's going to talk about this later in logs. He's going to do a whole chapter on this. Or maybe that's Mr. Kelly. One of those guys is. I think Mr. Sullivan's going to do rational functions. We're going to do a whole chapter. This is the most basic rational function. What I want you to know is it's got an asymptote here. It's got an asymptote here. And then it's going to hit these 2 points right here. So it's going to go through 1, 1. And follow those asymptotes because you can't divide by 0. So this is what happens. You can't divide by 0, so you've got these asymptotes. We're going to spend a lot of time on rational functions, but that's the most basic one, which you can move around like this. Where in the world is h and k? It's actually the origin in this one. We're going to actually move the asymptotes around, that division by 0. So this is what it looks like if you had to pull the a's on top there. I guess you could put the a in front and go 1 over if you wanted. But if you want to find the b, it would be down here in bottom. Now we've got all 8 functions, so we got to be able to work with those, handle those. All right, here we go. Let's put it all together and graph one of these bad boys. So let's see. Let's make sure we can identify all the parts, which like we've been doing. So this is a square root function, and a square root, hopefully recognize this when 1 makes 1. Square root of 1 is 1. 1, 2, 3, 4. Square root of 4 is 2. So this is the parent function. So a lot of times I'll give this to you, but hopefully we can sketch a little rough graph. That's the original. Now we're going to do all this stuff to it and see what happens to it. So let's start identifying. Remember, inside here would be what? This would be a horizontal shift. And which way are we going? We are actually going to go left 1. Everything in here is opposite of what you think. Then out here on the outside, what is this going to do? This is going to be that vertical shift. Vertical. And where are we going to go? We are going to go down 3. We got this 2 on the outside. What does he do? That would be our stretch. We're going to stretch it out a little bit. And we are what? In this case, we are doubling it. So vertical stretch by 2. And then don't forget the negative in front. We have this negative in front. And that is going to be our vertical, this is out front, reflection. So that'll flip it around the x-axis. Awesome. So when I go to graph this thing, I have to have a set of rules. Everything in math has got these rules. So here are the rules over here. Stretch, that really means the scale factor. How much am I changing it? But a lot of people just call it the stretchiness of it. Then we reflect it and we translate it. Really, the rules don't matter so much except for translation. You got to do that last. So if you can think of SRT, kind of reminds me of a reading test or something we all take here. If we can do the stretch, reflect, translate, then we're all going to get the same graph. It's like following an order of operations. If we don't, we're going to get different graphs if you start to translate your graph first. So let's stretch it. So this was my original. So what am I going to do? I've got this vertical stretch by 2. I'm going to double all these points. So he was at 1, he becomes 2. This guy right here was at 2, he becomes 4. So I've stretched this thing out vertically. Boom, there it is. So I took care of my stretch. I used purple for my stretch. Let's color this in a little purple so you know that's what I did there. Then what am I going to do? I'm going to reflect it. Let's reflect in green here. So in green, I'm going to reflect it. What does that mean? Well, I'm doing a vertical reflection, so I'm going to flip it around this axis. Whoop. And then these points just flip down. So you're going to take all your y values. It was positive 2, becomes negative 2. 0 is great because it stays 0. This bad boy up here becomes negative 4. And this whole idea will help you in the application. Oh, I love the application on this one. Boom. So there's my reflection. I did that in green. Now, finally, once we've done that, we can slide it around. And I'm going to do the translation in black. So let's move the green one over. I've got to shift it over 1. So this point 0, 0 goes over 1, down 3. 1, 2, 3. There it is. Just do each point individually. We're going to shift this guy over 1, down 1, 2, 3. And shift him over 1, down 1, 2, 3. So he's actually off the graph. Sorry about that. A little bit. There it is. So that's the final one. We should all end up at the black one right here. That is the correct answer. I'll draw a little smiley face by it because we're done. And we are good to go. A good little trick here if you want to check your points. If you want to make sure you're right, is to check your points. So what I always do is I kind of plot some points and try to pick points that are around h and k. So they're going to be around the vertex of this thing. So I know by looking at this that at -1 should make -3. That's the vertex. That's the h and k. So I know I went over 1 down 3. I know I got that right. So pick points around it. Well, there's no point to the left in this. So what am I going to do? Pick a point to the right of it. That would be 0. If I plug 0 in this, I'm going to say what? Plug it into your equation for x and solve it. So the square root of 1 is 1 times that's -2, you get -5. Is that where I am? -0, -5? 1, 2, 3, 4, 5. Yes. And then go ahead and plug 1 in. 1's not going to be so friendly, but you can still plug it in, right, and get a rough idea. 1 plus 1 is 2. Well, the square root of 2 is a decimal, but you can still put it in your calculator and approximate. Yeah, it's going to be somewhere down here. So I'm not going to find that with a calculator. If you want to, you can, but it should get you ballpark right in this neighborhood, and we should see we're good to go. So you can always plot points if you don't know what you're graphing. Plot points, pick some points around h and k to get you going, and hopefully that helps out. I'm going to end you with one of Mr. Bean's favorite songs. Good luck on the math check. Peace out.